Hi everyone. Good evening, good morning, good afternoon. I don't know. So yeah, we are starting the chapter 2 of the guessing game, right? And yeah, uh, of the Rust programming language. And chapter 2 is about creating a guessing game. So yeah, let's get started right away. So yeah, I'll be uploading this into GitHub. So yeah, cargo, we start by running cargo, and then yeah, let's call it guessing game. So yeah, all right, I guess we should create it first, and then what is wrong? Okay, so yeah, we got to, and then cargo new guessing game. Okay, right. So yeah, it will be a guessing game of a you have user input, and then yeah, basic generates a random number and then checks for user input, and if it's correct, and then it quits, right? So yeah, let's check our cargo tom file. Yeah, so okay, we have our source main as we discussed in the previous video, and we have this macro here that prints function main, and then the macro that prints on a string on the screen. So yeah, let's try it. Cargo run. Okay, cargo dot could not find cargo.tom. Okay, so yeah, basically yeah, we have a nested folder here. Okay, this is weird. Okay, I see what the problem is. So yeah, let's move this. Okay, so yeah, you just rename this. Then we delete this one here. Okay, so yeah, let's open a new terminal. Yeah, so yeah, it's working out properly. So yeah, we have to be on the same folder, right? So basically here you will use a library. Okay, so yeah, guess the number and input guess, and okay, so let's, I suppose this is like a standard library for Rust. Yeah, standard IO, standard input output, pretty much like C. So we print line guess the number, and yeah, we have this, I believe this is similar, it reminds me of JavaScript, like we have this let keyword to declare a variable, and then it calls this string class, and it declares creates a new instance of using new keywords, pretty much like Java and C#, language like that. So it's similar actually if you think about it, about JavaScript syntax, and these two columns here reminds me of C++. Okay, let's say input equals new, actually string new, I guess it's like this. So then it calls for standard input and this function here. I just simply print this and copy and paste this. So it's calls a standard IO, a standard input, read line. So here we have to overwrite this. Okay. Let's mute. Okay. So mute. So I guess this is a keyword. So let's go over line by line. Okay, to obtain user input and then print the result as an output, we need to bring the IO input output library to scope. Okay, so this is this line here. And let me increase this a little bit. The IO library comes from the standard library known as std. Okay. By default, Rust has a set of items defined in the standard library that brings into the scope of every program. The set is called the prelude. So it's pretty much like header files. You can see program structure, you have the header files. Python, you have the packages you're importing and such. Let me check something real quick here. Okay, so now we have our main function. The fn syntax because a new function. Okay, declare the no parameters. The curly brackets, the scope of the body. Okay. Print line, the macro. Okay. Storing values with variables. Okay. So next we create a variable to store the user input like this. Let mute guess. So I call this input string new. Okay. Use the let statement to create the variable. Here's another example. Let apples equal 4. The line creates a new variable named apples and binds to the value of 4. In Rust, variables are immutable by default, meaning once we give the variable value, the value won't change. So it acts like a constant, right? You'll be discussing this topic in detail in the variables and mutability section in chapter 3. To make a variable mutable, we add the mute before the variable name. Okay, so now we can change this variable here. And also to comment code snippet, we also use double slash. Returning to the guessing game program, you know that let mute guess will introduce a mutable variable named guess. Okay, let's just use the same here for this to stick to the example. And so this mute here is a keyword in Rust to ensure that it is mutable. Okay, so we can change the variable. Equal sign Rust tells me we want to bind something to the variable now. On the right of the equal sign is result string new. a function returns a new instance of a string. So a string is a string type, pretty much like C++, and yeah, I believe JavaScript has the class string, and yeah, Python also. But Python, we don't have a strong typing. It's pretty much dynamic typing. The double column syntax in the new line indicates the new is the associated function of the string type. So this class string associated function, the function that's implemented on a type, in this case string. This new function creates a new empty string. You find a new function many times because it's a common name for a function that makes a new variable of some kind. So yeah, it's pretty much like Java and C# and yeah. In full, let mutable guess string new line has created a mutable variable that is currently bound to a new empty instance of a string. Receiving user input. Recall that we included use standard IO on the first line of program. Now we call the standard input function from the IO module, which will allow us to handle user input. Okay, so standard, rewriting this function call as standard input. The standard input function returns an instance of standard IO standard input, which is a type that represents a handle to the standard input for a terminal. Okay. So we're guessing this right here. And the next line, readline calls the readline method on the standard input handle. Okay, we are passing mutable guess as the argument to the readline to tell it what string to store the input here. So I guessing this here works like pretty much like a reference, like in C and C++. We have a reference to the point. We have a pointer to this guess variable here in memory, and then yeah, pretty much like scanf, you pass a reference to the variable. Like for job reliance to take whatever user types into standard appended to the string. String argument needs to be mutable so the method can change the string content. So the sign here indicates that the argument is a reference. Yeah, so as I was saying, as I was suspecting, it's pretty much like C, C#, C++, and so on. Which gives a way to let multiple parts of code access one piece of data without needing to copy that data into memory multiple times. Yeah, so it's passing by reference. Reference a complex feature, one rules, one is advantage, also okay. So yeah, it's pretty much like scanf and C, where you pass the reference of the buffer or variable you were storing. Okay. Handling potential failure with results. We're still working. Still working on this line of code. We're not discussing a third line of text, but note that it's still part of a single logical line of code. And the next part is this expect failure to read line. We could have written this. Okay, so it's how it is here. Okay, difficult to read. Readline puts whatever the user enters into the string we pass it, but it also returns a result value. So we have any type hints here? No. Yeah. Results in enumeration, often called an enum, which is a type that can be in multiple possible states. We call each possible state a variant. Okay, chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Okay, results variants are OK and error. The OK variant indicates the operation was successful, and set OK is the successful generated value. Error variant means the operation failed, and error contains information about how or why the operation failed. Values of the result type, like types of any value, have methods defined on that. And instance the result has an expect method, so okay, we're calling this expect method here. If this instance of result is an error type, expect will cause the program to crash and display the message that you pass as an argument to expect. Okay. If the readline method returns an error, it would be the result of an error coming from the underlying operating system. If this instance of result is OK value, expect to take to the return value that OK is holding in. Return just that value so you can use it. Okay, if you don't call expect, the program will compile, but you get a warning. Okay, so if we don't use that method expect, the compiler will turn us that the error should be handled in some form. So yeah, this is how we would handle the error this case here. Rust warns that you haven't used the result value returned from readline, indicating that the program hasn't handled possible error. Okay, so let's try that. Cargo run. Okay, so nothing happened, so let's strip this off here. And then cargo run. Yeah, so we get this result may be an error variant which should be handled. Okay, so yeah, let's leave it. Yeah, the right way to suppress the warning is to actually write error handling code, but in your case we just want to crash the program when a problem occurs, so we can use expect. You'll learn about recovering from errors in chapter 9. Okay, what is chapter 9? So here's chapter 6 in nums, and chapter 9 is okay, is error handling, so we got there. Okay, printing values with print line placeholders. Okay, aside from the curl closing curly bracket, there's only one more line to disclose in the curl so far. So okay, so use curly brackets pretty much like formatted string in Python. So yeah. Then let's print line. You guess it, and then oops. Yeah, so that's it. So let's try to run. Okay, so it's working. The syntax highlighting doesn't really help that much, but yeah. So yeah, so it's pretty much like JavaScript and Python. Yeah. Printing a variable and the result of a special one call to print line would look like this. Okay, so I guess we could do something like and then like this. Yeah. So there's two ways we could do it. So like this, and then like this. So there's two ways we could do it. I just keep this line commented here. So yeah, pretty much if you're familiar with JavaScript, this is very familiar. But here in this case it will be immutable, right? So it's equivalent to declaring this as a const in JavaScript or C, C++, so we have. And Okay. So yeah, we tested with cargo run, it's working. So generate a secret number. So yeah, we have to use some library probably to generate a random variable, right? Using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we'll be building is a binary crate, which is an executable. The rand crate is a library crate, which contains code that's intended to be used in other programs. Cargo's coordinates external cases where cargo shines. We need to modify the cargo tom file to include the rand crate as a dependency. Open that file now and add the font to the bottom beneath the dependency section header that cargo created for you. Be sure to specify rand exactly as we have here with this version number, or the code example may not work. So yeah, we simply copy and paste that here in the cargo.tom file. So yeah, if you use a package manager like Maven from Java, if I'm not mistaken, it also works similar like this. So yeah, and okay, so what? So in this cargo, okay, semantic versioning. Now without changing any code, let's build the project. Let's show a listing. So yeah, let's run cargo build. Okay, so it's probably downloading that library that I just included. So it's pretty much like if you know Python, like pip install, or yeah, Maven package like from Java. Yeah, so something along those lines. So npm install, if you're familiar with Node.js, right? So the only fork rates, yeah, so it's done. Cargo builds, you may see different numbers after this. You check cargo checks dependency section, downloads. If you need to run cargo again without making any changes, you won't get any output aside from the finish line. So let's run again to check. Yeah, it's already up, unoptimized, debug info. Okay. Source main.rs file, make a trivial change and then save it, build again. You only see 2 lines of output. Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Cargo uses only the versions of the dependencies you specify until indicated otherwise. See you next week. Version 0.8.6 of the rand crate comes out, and this version contains an important bug fix. It also contains a regression to break your code. Now this create cargo.log file. So now we have this in the guessing game directory. Okay, so let's check it out. So yeah, it's pretty much like npm also has something like this. So yeah, package guessing game. Here are our packages, rand, the version, the checksums, the source. Yeah. So this will be in the git gnar file. And I believe there's also some, I guess it should be here. Yeah. So we should place our git gnar file inside guessing game directory created by cargo new, right? Updating a crate to get a new version. When you do want to update a crate, so yeah, it's pretty much like if this file here is like when it generates a requirements.txt, like using pip. It's from Python, right? So okay, back to we can run cargo update. Cargo.log file. So yeah, let's try run cargo update. Okay, so nothing happened. Cargo with them right versions, otherwise by default to look video. To use rand version 0.9.0 or any version, you have to update the cargo.tom file to look like this instead. So next time you'll run cargo build, cargo update the registry of crates available and reevaluate your rand requirements. We discussed in chapter 14, but for now that's all I need to know. Okay, so let's try this right here and run cargo update. Yeah, fail to select a version for the requirement. Okay, let's try run cargo build, I guess. And yeah, it didn't work because okay, so 0.8.5, so yeah, let's just leave like that and then okay. Yeah, so it's giving an example. Okay, so let's start using the rand library to generate a number to guess. The next steps update source.main. Okay, so we use this other library, rand RNG, random number generator, guessing. So it's probably the class that we're using from this library, probably. Yeah. Okay, secret number. Yeah, so here is the line that calls this class and then this method and then the range. Okay, so we will generate a random number from 1 to 100. Okay, I will make it a little bit different. So yeah, let's group this variables declaration here, and yeah, let's leave it between 1 and 10. Okay, then reads line, and then prints the number I guessed. Right. So yeah, first we had line use, okay, methods, call the rand thread RNG random number generator function that gives a particular random number you're going to use. Okay, one that is local to the current thread of the execution and is seeded by the operating system. So I guess it's yeah, and we call the generator range method. On the run of this method is defined ID RNG trait that we brought into scope with use rand RNG statement. The next range takes a range expression as an argument and generates a random number in the range. Okay, this kind of range expression we're using here takes from start dot equal end and is inclusive on the lower and upper bound. So yeah, it's lower and upper included. 1 dot equals 100 to request an maximum 100. No, what you want to know, you won't just know which traits to use and which methods and functions to call for a crate. So each crate has a documentation with instructions on using it. Another neat feature cargo is that running cargo doc dash open command will build a documentation provided about all your dependencies locally and open it in your browser. If you're interested in the other functionality in the rand crate, for example, run cargo doc dash open and click rand in the sidebar on the left. So yeah, we'll try that, and I'll be back in just a second. So yeah, I'm right back, and yeah, we can check that later. Cargo doc. cargo. Okay, so it's building the documentation, I guess, and yeah. And dash open. Okay, so it opened this file right here. We have get random, rand. Oh, that's really nice. Quick start. Yes, so yeah, this is really nice. So we have all this documentation, how to use the library and such. Yeah. Okay, I'm closing this and going back to here, and yeah, so we generate our random number. Okay, try running the program a few times. So let's try displaying this random number here. And then secret number, cargo run. Okay, so generated 4, so let's try one more time. Yeah, so it seems to be working. And okay. Yeah, I should get different random numbers and they all should be okay. So instead we want running between 1 and 100, we run between 1 and 10. So yeah, comparing the guess to the secret number. So we use this library here, standard compare ordering. So let's print this, let's copy this. Now that we have user input and random number, we can compare that. An exception in listing, okay. Okay, so we use this another library called standard from compare from standard, and yeah, we pass the secret number as a reference, and then we use ordering this class here to check if it is less, greater, or equal. Okay. So yeah, let's copy this. And run cargo run. I think we need to run cargo build first. Oops, what's going on? Spec struct string found integer. Okay, so there's a few more details we need to go here. So yeah, expecting to throw this error. So yeah, use other statement, bring a type called standard compare ordering to scope. For instance, like the ordering type is another enum and has the variance less, greater, and equal. So yeah, these are, it's called variants. These are the 3 outcomes that are possible when you compare two values. And then final lines, okay, compare method compares two values. Okay, so it's pretty straightforward. Match expression is made up of arms. Yeah, so I'm guessing this like the switch statement from C, Yeah, it reminds me a little bit of the switch statement, switch keyword. So yeah, you have a variable, then switch case, and then breaks, and a pattern to match against, and the code that should be run if the value given to the match fits the arms pattern. Rust takes the value given to match and looks through each arms pattern and run. Yeah, so I guess it's pretty much like a switch statement we have in C and C++. Yeah, the code won't compile yet, so yeah, I already tried to compile and it throws this error here. Arguments to this function are incorrect, so yeah, it's expecting a string, but this is a integer. Okay, so this here is a integer, and I guess to compare we have to convert it to a string. Expect a reference string from reference integer. Yes. Okay. So yeah, I guess we have to do some type conversion. Mismatch types. Rust has a strong static type system. However, it also has type inference. When we wrote let mutable guess equals string new, Rust was able to infer that guess should be a type string. Yeah, so I guess C# has something like that when you create a var type and then it infers the type. And yeah, I guess Java also, but I'm not sure. Few Rust types have a value between 1 and 100. I32 is a 32-bit number, U32 is unsigned 32-bit, I64 and so on, yeah. Unless otherwise specified, Rust defaults to I32, which is the type of value secret number. Okay, the reason for the errors cannot compare a string and number type. Ultimately, we want to convert a string. The program reads as input into a real number type so we can compare it numerically. And let me do something real quick here. Okay. So yeah, we want to convert the string the program reads as an input into a real number type so we can compare numerically. Okay, so yeah, this is the string we read, and then we create another guess variable, which is a unsigned 32-bit. So yeah, this is a lot of. Okay, and then we throw an error if it is not a number, I guess. Right. So, yeah. So we take the string, trim, parse. Yeah, there are a lot of methods here. So yeah, just I think that strikes me is that okay, so we are using the same variable name here, which is weird. We create a variable name guess, but wait, doesn't the program already have a variable name guess? It does, but hopefully Rust allows us to shadow the previous value of guess with a new one. Okay, so we are overriding it. I guess similar shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guess string and guess, for example. We'll cover this in more detail in chapter 3. Yeah, for me as a C developer, it's Python. Yeah, Python has something similar, but yeah, it sounds a little bit weird to me, at least at this point. But I guess it will make sense from more on. We know this feature is often used when you want to convert a value from one type to another type. So yeah, it will be equivalent to sort of typecasting. We bind this variable expression guess.train.parse. The guess is especially refers to the original guess variable that contains the input to the string. The train method on a string instance will eliminate any white space. Okay, so that's why we need this white space in the beginning and the end, which we must be able to compare the string to the unsigned 32-bit integer. We can only contain marked data. User must press enter to satisfy read line and put their guess, which adds a new line character to the string. Yeah, so if we're doing this in C and C++, we have to do all this heavy lifting, and that's pretty annoying. Yeah, it facilitates a lot your programming in that regard. So if there's presses user types phi, parse enter guess looks like this, and then here double inverted dash represents new line. Character return and a new line, and then the string eliminates these characters here. Oops. Parse method on strings converts the string to another type. Here we use it to convert it from a string to a number. We need to tell Rust the exact number we want by using let guess and sign 32. Okay, so this column here is to tell Rust to annotate the variables type. So I believe Golang has this, yeah, it has a similar syntax, but it will be like colon then equals, and yeah. So if you're familiar with Golang, it's something along those lines. It's a good default choice for a small positive number. Learn about other numeric types, chapter 3. Okay, so it's the next chapter. Additionally, don't sign 32 notation, the example program, the comparison. Rust to infer the secret number should be on side 32 as well. So now the comparison will be between two variables of the same type. Okay. The parse method will only work on characters that cannot be converted into numbers, and so can easily cause errors. So yeah, we could send an emoji to the string, to the input. Yeah, there will be no way to convert it at a number, unless you're using JavaScript, of course, because you know JavaScript is weird, right? Because it might fail, the parse returns the result type. Okay, so we use again the expect here to handle error. So let's try running this now, and then cargo run. Let's type 5. Yeah, it's too small. And then 7, too big. Yeah, so now it's working. So I guess we already have the program here. And let's try winning this. And I keep guessing 5. Yeah, so I guess it's 5, and then yeah. So you guess 5, random number generate. Okay. So I guess it's working properly. Is there something else to expect method? Returns an error, result, and okay, variant of result on right. Nice. Even through, let's try with I don't know. Yeah. Parse int error. Yeah, so please type another parse int error. So yeah, let's try. Please type another parse int invalid digit. So I guess there isn't a an error that is handled here. Yeah, allowing multiple guesses with looping. So let's try adding a space, one with space. Yeah, it worked. And then 1, 2, 3. Yeah, then we managed to break the program. So if we add number 1 and like a lot of spaces here, it works. So yeah, it managed to remove the spaces here with the trim. Okay. Yeah. Run from a few times to verify the different behavior with different kinds of input. Guess them correctly. Okay. The user can only make one guess. Okay, so we add a loop. The loop keyword creates infinity loops. So yeah, it's like writing while true in Python or C, C++, right? And then we use loop and yeah, create curly brackets like this. So yeah. So please input your guess. I guess we generate a secret number at once, and then we loop this whole thing here. Let me ident this properly. Yeah. So let's try it. Oops. Parse int error. It breaks after. Okay, read line. Yeah, this is weird. Let me check something. Okay. Please input. So we read line and typing quickly, but I notice so you went to a non-number input. Okay, so just a second, I'll be right back. Okay. Okay, I think we can go back to where we were in the tutorial, and yeah. So yeah, I noticed that when we implemented this loop here, the program started breaking. Yeah, I don't know why really. Probably we have to do some flushing on this variable. So yeah, let's go back to it. Okay, we were on the loop keyword, right? To create an infinity loop, so pretty much like a while true in JavaScript and yeah, you know, Python and such. So let me please input your guess and where was it? Okay, never mind. Move everything from guess input onwards into a loop. Be sure to indent the lines inside the loop for another first bit. Okay. We now ask for another guess forever, which actually introduces a new problem. It doesn't seem like the user can quit. The user could always enter the program by using. I guess we should include this inside the loop or the secret number. Yeah, I think we everything should be inside the loop. And then yeah, let's try running again. Yeah, so as I was thinking, everything must be wrapped inside the loop for it to doesn't break. So yeah, now we can quit. We simply can't quit the program because it stay on the loop forever. Yeah, so probably has to do with this mutable thing, or yeah, I don't know really why, but to solve that we should wrap everything up inside this loop here. Okay, so we could generate a secret number only once. So yeah, let's try moving this outside the loop, and then only the string, which we'll guess we have to create a new instance every iteration of the loop. So yeah, let's try it. Guess the number. Let me check something real quick. Yeah. Okay, yeah, so the problem was with the string input, like the buffer for the input, that we were having a problem, and it was making the program crash. Yeah. So okay, so we have to type a Control-C to exit the program. And yeah, so this can stay outside the loop. So yeah, back to it. Then the line, okay. The user grows into the Control-C, but there is another way to escape this insatiable monster, as we mentioned in the parts discussion. If the user enters a known number answer, the program will crash. We can take advantage of that to allow the user to quit, as shown here. Typing quit will quit the game, but as you notice, so will enter any other known number input. Yeah, so yeah, this is bad, right? So quitting after a correct guess. Let's program going to quit when the user wins by adding a break statement. Yeah, so this is pretty much like, you know, a switch case in Front-C, right? So yeah, equal, and then I guess we open a new context here. How do you call that in C? A scope, right? Curly brackets in C, in C++, JavaScript, Java define a scope. So here we create a new scope, and we print this, and okay, and yeah, break. So this will break from this loop here. So yeah, while true, and then so this isn't exactly like a switch case, because in every case your switch enters, you have to break, and then here it would have to break twice. So yeah, that doesn't make sense. But you can think of that. You can think that it's a switch case with the break keyword already implemented here of sorts. So yeah, here actually we're not breaking from here, but actually we're breaking from this loop, right? So okay, back to it. We print you win. Yeah, so let's try that if it works. 1, 2, 3, 4. So I keep guessing 5 and 2. Yeah, because we have to wrap this now inside here, otherwise it won't generate. It will generate a number, a random number on one single time, and then yeah. Or we could simply leave this like this and simply don't print the number. Yeah, so let's leave this out here, and then let me clear this. Cargo run. Okay, so keep guessing 5. Too big. Okay. So 4. Yeah. So it works. And let's try again. And 3 too small, 4, 5, 6, 7, 8, 9, and must be 10. Okay. Adding the break line after you win makes the program exit the loop when the user gets the secret number correctly. Exiting the loop also means exiting the program because the loop is the last part of main. Okay, let me check back again this ordering here. This doesn't seem really clear to me, and this match. Okay, it's made of arms, Spartan to match against, and yeah, let me check something on Stack Overflow because this is giving me a headache. Match equivalent, Rust switch. Okay, so I found what I was looking for. So why did Rust go with match instead of switch or case? So I guess there must be a good reason for this, right? I would assume switch would appeal to C, C++, Java, etc. And thus be a natural choice. Yeah, I'm having the same feeling. Okay, Ocon as an influence for pattern matching. Ocon pattern matching uses the match keyword. Okay, so it comes from this other language here. The original Rust compile was written in Ocon, so it makes sense that Ocon would have had a stronger influence on Rust than, say, Haskell. Okay, so that explains it. So yeah, it would be equivalent to a switch case. So yeah, that answers my question. Let me check YouTube if there is anyone here. So for you that is watching right now, in case you haven't subscribed yet, don't forget to like and subscribe, and let me know in the chat if you have any questions. I guess I'm also new to Rust, as you probably are. So yeah, if you have a question, I would try to answer it to my very beginner knowledge of Rust. But yeah, so let's go back to where we were. Okay, break. Handling invalid input. I still have water here. I guess I do. So yeah. Okay. So to further refine the game's behavior rather than crashing the program with the users, and the user inputs a known number, let's make the game ignore a known number so the user can continue guessing. We can do that by altering the line where guess is converted from the string to an unsigned 32 integer, as shown here. Okay. So yeah, so this is the string buffer that we have, and then we'll remove the new space characters and so on, and then parse it. If it's okay, then we convert, and in case there's an error, we have this other keyword continue. So we switch from an expect call to a match expression. So let me check here. Where is it? Okay. So we have here.expect parse, and now we open. Okay, we call parse, and then we open brackets here. And in case there's everything okay, I guess we convert. This is starting to look like a functional programming syntax to me, but I might be mistaken regarding this. So yeah, to a match expression to move from crashing to an error to handling the error. Remember, the parse returns the result type, so it's a class, right? Results is an enum that has the variance OK and error. Okay, we're using a match expression here as we did with the ordering results of the compare method. If parse is able to successfully turn the string to a number, it will return an OK value, so it's from this enum here, right? That contains the resultant number. That OK value will match the first arm's pattern, so yeah, this one right here. And the match expression will return the num value that parse produce and put inside the OK value. That number will end up right where we want. Okay. If parse is not able to turn the string to a number, it will return an error value, so it's it's a num, right? Okay. More information about the error. That does not match pattern, but it does match the error pattern in the second arm here. Okay. The underscore is a catch-all value. So yeah, we're seeing. So like it's a general. Like when we use in Python, for example, we have a exception that it will catches all exception types that inherit. It's a class, right? So it inherits all behavior from whatever exception it's inheriting, right? So no matter what information they have inside it, so the program will execute the second arm's code, continue, which tells the program to go to the next iteration of the loop and asks for another guess. Okay, so if we have an invalid character here, and then in case it won't be able to parse here, then it will simply ignore it and continue. Yeah, so in fact the program ignores all errors that are parsed, so this function here, this method, might encounter. Okay, so let's try it. Where is it? Okay, so let me comment this line here just so just for the sake of remember how we were dealing with it. So now we handle the error. So it's like a try-catch expression, I guess, of sorts. I don't know if Rust has something similar to a try-catch or try-except, and yeah, because you know in Java it's try-catch and Python is try-except. Finally, yeah, and so on, right? Okay, so let's try it, run this, and so I'm gonna try something. Yeah, it simply ignores the error and carries on. So yeah, I would try to break this any way possible. Yeah, so it's working. Yeah, it seems to be working and ignoring errors, right? Okay, we switch from an expect call to a match expression to move from crashing on an error to handling the error. So we could do this, I guess, also here to, yeah, in case we fail to read a line from user input. And okay, as it's already said, result is a num that has the variance OK and error. This concept here in Rust of variance is still not quite clear to me, so I guess it will become more clear on chapter of in 6, which talks about enums, I guess. So yeah, we're using match expression here as we did with ordering results of the compare method. So yes, match. So it's like a switch case, and here in this case here we do this, and this case we do this. And yeah, so it's pretty much the case. And then what happens if it if it reaches that case, right? If parse is able to successfully turn string 0, okay. Parse produce inside OK value. Okay, we already went through that. Right. Yeah, recall the program. So yeah, we already took care of that, of printing the secret number. So yeah, here it stayed outside the loop, so it generates the random number only once, and then yeah, we have to guess the number. And yeah, we ended up pretty much with a program that is similar to the example here, except that we don't have this line here, but it's simply printing the title of the program. Yeah. So I guess this is it. We have we reached the end of this example. I want to analyze the code again and make some final remarks. So yeah, let's check the summary. So this project was a hands-on way to introduce you to many Rust concepts, let, match, functions, the use of external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Okay, so let me check something in Stack Overflow, which is I'm having a certain doubt. Okay. So yeah, I guess I'm getting a little bit ahead of myself here, but yeah, I was in doubt regarding this enum here in Rust, and yeah, so enums in Rust are similar to those compiled languages like C, but have important difference that makes them considerably more powerful. What Rust calls enums are more commonly known as algebraic data types. If you're coming from a functional programming background, okay, so I don't have any function programming background, it's not my case. Important detail is that each enum variant can have data to go along with it. Okay, so the variants in an enum data type, which is the case of the result here, that comes from readline and also parse. These are the variants of the enum, right? And okay. So let me check something else. Enum results Rust. Okay, so this is the enum that we are working with in Rust. So it's from standard library from Rust. And this looks like a template syntax from C++. Yeah, and have OK and error. If you think about it, it's pretty similar to Golang, which you can return an error type and then we check if it's new or something like that. Yeah. So it's an enum of the results of a, I don't know, of a certain method, and then OK, the OK contains the success value and the error. The error contains the error value, right? We have implementations, I guess, so this is sort of a interface or a template. It reminds me of a template of C++. So yeah, here basic usage, implementations. Okay, so this is getting we're getting a little bit ahead of ourselves here. This is a more advanced topic, so yeah, let's get back to a program here and analyze it. So on this tutorial we start using a libraries from Rust. We use a standard library here from handling user inputs. Then the standard library for compare and ordering, which we use here. So guess.compare. Okay, and we use also an external library which we install using which is called again external crates. That's how it's called. It's a crate, and we run it with let me check. Okay, cargo update, right? So we include it in this where is the cargo.tom file. The dependency is pretty much like a requirements.txt from Python, a file from Maven. If you're familiar with JavaScript, with Java, which uses Maven for package management, and pretty much like npm and so on. You have tons of different package managers. Then we included this here and then installed the library for us. So this is example uses libraries. We learn how to declare a variable using let, which is similar to JavaScript, when you can declare a variable using let. Here, if we omit this mute here, it will assume that is a constant, so it's an immutable type. But if you want to change this value, this variable along the program, the execution of the program, we have to use this mute keyword to indicate that it's indeed mutable. Okay, hi, Dr. JP, I guess that's correct. Yeah. So, hi, Dr. JP, right. We are almost at ending here, but you can stay if you want to. You can ask questions if you want to. And okay, so I was talking as reviewing what we did. So this string here comes, I guess, from standard library. I don't know. So we declare this using new keyword, this new method, which is similar to how to declare a string class in JavaScript. So Java, So in Java it would be something like the string gas equals new string, so something like that. So there are a lot of similarities with other languages, and in JavaScript you would do something like let gas, and then simply let JavaScript do its stuff, and Python, you don't have to do anything like that. And here we create an infinite loop, which in C++ or C would be something like while one or while true, and then curly brackets. Also Python, we use while true here for creating an infinite loop. And there are sorts of we can create a infinite loop like this, also using for in C. So and then we use this print line macro, which is exactly a function we use in our first example. And then this syntax here, I found it pretty much this usage here reminds me of the namespaces that you have in C++, like you have the namespace standard, right? And in C++ you do something like this: std cin, and then inputs, and then read some inputs, and then if you want to print something, it's standard out, and then some string here, some text, and then you can do something like this: with a string variable and then std and line, right? And Python is much more simpler. Of course, we have simply if you want to read inputs, we simply take a guess equals inputs like this, and it's done. So yeah, you can compare really the syntax from Rust with Python, right? So Python is much more simpler. We have dynamic typing, so yeah, it will make more sense to compare this to either a functional programming language or C++ itself. So yeah, it has some similarities with C++, right, and JavaScript. Yeah, you can see influences from a lot of different languages here, really. So yeah, so we call this from the standard input library, standard input readline, and then we use this symbol for reference, which is pretty much the syntax of C and C++. So we pass this value by reference to this function here, and then it will fill the string with whatever the user inputs. And then if it fails, we print this exception here. And then also Rust has a system of guessing the type of the variable. So I guess in C# it would be something like var secret number equals to I don't know, something here, and then it will guess the type. So Rust has this by standard, which is very nice, or we can specify the type using column, and then in this case an unsigned 32-bit integer, like it will be equivalent to, let's say in C we'll have something like this, int gas. Okay, so int is generally is not always a 32 bits. In some systems it can be 32 bits, which it would correspond to 4 bytes, right? So in some systems it could be 8 or 2, so it really depends. So if you want here a u32 unsigned int, in C we have to use something like this, a uint 32. Yeah, so whoops. And then we have this match keyword from Rust, and yeah, as I looked up on Stack Overflow, it comes from Occam, which is another programming language which I had never have worked with. And yeah, if you're going to make an analogy with C and C++, it will correspond to a switch case, and then here we have the different cases, right? And yeah, so this guess is a string, so it has this method here, trim, where it removes the new lines, and you know, characters like a for example, which stands for new line, carriage return, which also we have C, also I believe tab also, and new lines of sorts. So yeah, removes all sorts of special characters, and then it parses it into this variable here that that we're trying to convert, right? So Rust, at first it sounds weird to me that where Rust allows it for use the same variable name here. So like if you do this, if you try to do this in C or C++, it would throw an error because we can use the same variable name twice. But here Rust allows this, and it allows us to do a type conversion, or in C, C++, you will call it a typecasting here. And yeah, so it returns an enum, which is a result, and it has this what Rust calls variant, which is okay at error. So whatever error it throws here by this, which we determine by this underscore underline here, we simply continue, and so we decided to continue with the program execution regardless of if it throws an error, throws an exception. And then yeah, we have this syntax here for printing line, which is pretty similar to Python. And yeah, we could also do something like this, which is similar to Python syntax and also I believe JavaScript syntax. You guess it. And then but in Python you have to use a like f string here of sorts, and Java simply, yeah, I believe you do JavaScript, you do it like this and don't have to specify this f here. So yeah, I will leave this. I guess I should switch this to here. Okay, so we have two forms of printing this variable here. And finally, yeah, we use this compare, which is from this. Okay, it's a library compare from, and then we use this class ordering to check if it is less, greater, or equal. This sounds strange to me because, you know, in C, C++, or Python, it would do something like this. If secret number, if guess is greater, is less than secret number, then we print a let's say we see, right? So print line too small, and then here's some new line, something like this, and else if guess it's greater than secret number. Yeah, so it will be something along those lines in C. So yeah, this is so it will be inside a switch case statement, and it sounds, yeah, that sounds a little bit weird for me at first glance. So perhaps there is something we could implement this in some other way in Rust, which we'll get into, I believe. But yeah, at first glance, I found this a little bit strange as coming from a C, C++, and Python background. And yeah, finally here we use break, which is a keyword you also have in, I guess, Python as well, and C, C++, where we exit this loop, which, yeah, you know, as I said before, pointed out before, it corresponds to a while true, right? That's how you usually create an infinite loop in C, C++, and Python. So yeah, in case you don't have any questions, so I leave this space open here for some questions you might have. And you know, I believe you all, most of you are learning Rust as well from scratch. So this is your first time having contact with it. So yeah, I know probably as much as you do. So yeah, feel free to ask the question and we'll look into it. So yeah, the questions that I had, I already looked upon it on Stack Overflow and I got the answers to most of them. So yeah, in case you don't have any more questions, I'll be adding this part 2 here from chapter 2 from the Rust programming language book here. And yeah, we'll be seeing in the next time in chapter 3. Okay, everyone, so yeah, hope you all enjoy this tutorial, and